Hi, in this video I have a leaf blower and it is a 2800 watt unit, and here is the cord, and I'm going to just demonstrate the problem. So I plug it in, I'm going to press the button and I'm going to fiddle with the cord here, and notice that the blower cuts out. Right, this button is fully depressed. Look, even if I press it, nothing's happening, but watch when I wiggle the wire. So when I hold the wire in one position, the unit no longer works, and I'm going to demonstrate how to repair this. So the first thing is I need to disconnect it from the main, so it's completely off now, and now I need to unfortunately open all these screws. There are lots of screws here. Now these are just star screws. Now the blower section had this black plastic ring here, and this was holding it together. I just squeezed these two together and then I slid this off. Right, I've unscrewed all the screws. If you're finding that yours is still not opening, just check every single screw is loosened. I see here this one is not completely loosened. Right, now underneath there's a screw that is holding this together. So I have to be careful not to let all these screws fall out, and I just have to loosen this one screw underneath here. Right, now I can disassemble this. I'm going to remove the top from the unit. You might find that it is a bit stuck, and with a bit of wiggling I can get the top off. I'm not going to turn the top around, otherwise all the screws are going to fall out. I'm going to put it down just like this on the counter next to me. Right, so here is the cord and there's the strain relief, and I'm just going to open that. And obviously this harsh bend over here has damaged this cord. So I'm going to unscrew this clamp here, which is clamping down the cord, and I'm just going to replace the cord. Now the mains has the live wire going to that limit switch, and then the neutral is going directly to the motor. So I'm just going to allow this limit switch to come out. There is a spring there. Just be very careful. You don't want that spring flying off. So I'm just taking it out carefully. I'm disconnecting this terminal from this limit switch. And then on this side, I'm just disconnecting the neutral. Oh, interesting. And this just popped out as well. So there's also a little fault there that wasn't crimped properly. These two wires were supposed to be crimped inside that terminal, and they just pulled out. So that's another fault waiting to happen. And I just need to open this. This has heat shrink. And there is the connector, which I just need to pull out. Right. Right, just to be doubly sure that the fault was on this cord, I have my multimeter here, I have my two leads, and I've set it to continuity. Continuity means it's going to measure if there's a short circuit. So for example, if I put my leads over the screwdriver, we can hear the meter is making that beeping sign, and there I can see all the zeros telling me it's a short circuit. So if I open it, it's an open circuit. If I put this back on, it's a closed circuit. Right, I'm just opening this plug top. Now yours would be different depending on which country you reside in. So what I'm doing is I'm putting it on the one lead over here. Right, so there's the wire that was going to the mains, and I've connected it to my meter. So there we can see it was a very short cord there from the blower side, there on the main side. And now what I'm going to do is I'm going to wiggle this wire. There, look at that. Definitely a fault in this wire. So the fault was somewhere here, and I'll just open it up just to have a look inside. Right, and there's the fault. Notice how this is so flexible, and if I just go like that, look at that. The copper is broken. See there, the copper is broken inside. Right, so that was the fault. It fatigued over time, and now I'm going to repair it. Right, so here is replacement cord. It is the same capacity. Make sure that the replacement cord can handle the power rating of your unit. Now the cord that came from the manufacturer, it's specified at 2 times 1 millimeter squared wire. So I'm going to match it. You can even use thicker wire. Thicker is fine, but thinner is not acceptable. So my replacement cord that I'm using meets the same specification. It is 2 times 1 millimeter squared. This is my replacement cord, and I'm going to match it to the old cord. So I'm just going to put the strain relief on the new cord. So there I'm inserting the strain relief. This is very important. It reduces the harsh bend that may take place here, and this will extend the lifespan of the cord. Then on the old unit, it had this rubber washer. Right, there's the old one. I need to open the new protective covering here to get the two wires out. Now when I do this, I just cut lightly. I'm not cutting all the way through. It's like I'm making an indentation rather than cutting it. See there, I haven't cut all the way through. What I do is I bend this rather And once it starts tearing, I can just help it along with my finger. Now I just need to open it a little bit more at the back here. Right. The reason I do that is I don't want to cut in or break the protective covering of the live and neutral wire. Now I'm going to have to put a terminal on the live and the neutral. Now it's a good idea if you've got some spare terminals laying around and you can use new ones. I just need to expose about 1/2 centimeter, 5 millimeters of the bare copper. And this one has the protective cover already on, and then I insert it there. You can see it coming through there, and I can just crimp this. Now, most people don't have spares like this hanging around, so I'm going to show you what to do if you don't have those spares. Now, if we go back to the unit, we can see that these two wires were supposed to be crimped into this connector, and then the blue wire was supposed to be connected like that, and then this went in like that. Now, if you do not have these spare connectors, you can actually just shortcut this, and you can solder this and this directly to each other if you want to. So I've demonstrated how to do it using brand new connectors the correct way, but I understand that most people do not have these spares, and you can just go and solder directly to the wires. That's also acceptable. I am going to use some heat shrink. This is a protective covering that once it's heated, it shrinks. So I'm just going to put that on. If you don't have this, it's not a problem. You can use insulation tape, and I'll also demonstrate that. I'm just going to expose a bit more of the wire. I prefer to use wire strippers to remove the protective covering. When people use side cutters, they often cut too deep to remove the cover, and they remove some of these cores. That is not good practice. So make sure that all the cores are still present. And now using a soldering iron, I'm going to put solder here. I'm going to solder the blue wire to these two wires. I just cut away the burrs. Now that is soldered, and all I need to do now is cover it. So I'm just sliding on the heat shrink, and using a flame, I just heat this up a little bit to shrink it. And then I'll put a second layer just to have another layer of protection. Now, if you don't have heat shrink, it's not a problem. Just use a high quality insulation tape. And in your case, you would just tape over the join. So yours would look like that. Right, so now I just need to reassemble everything. All right, so there's the blue wire going to those two wires. Right, now I just need to seat this connector onto the limit switch. Now, if you don't have these terminals, you could just solder onto the terminal and then plug it in here. And in worst case scenario, you can actually solder on directly onto the limit switch, but just be careful not to melt the plastic. Right, so there's the connector on. Now, in order to get this wire back, I can see there's a space at the back of that limit switch. So I'm going to twist this around on the inside and let it run there at the bottom. Now I can just seat this limit switch. Notice there are these posts which align to these holes. And I just need to make sure the spring is depressed. There we go. So the spring is in place, the wire's at the bottom, and that will still work. Right, I don't want to put too much tension on this, so I'll just give a bit of free play there. Now for the blue wire, in this case, I can see there's also a space at the bottom there, so I can either run it around the side, but in this case, there is a space for the blue wire inside there, but that is actually uncommon. So in your case, you might be running it around the sides. And now I turn that clamp to hold in place. Right, before I tighten this, I do a quick check. What I want to see is that there is no tension on this wire pulling on this limit switch. There's quite a bit of free play there, and the blue wire, there's quite a bit of free play there as well. So now I can tighten this, and I don't need to tighten it very tight. I just need to tighten it a bit. Once it beds into the plastic or the rubber of the mains, I can just do a quick check, and I can see that this is going nowhere. Just be careful of tightening these too tight. Sometimes if you tighten it too tight, it just snaps here. Other times it beds too deep in here, and we find that it eventually damages when there's some movement. Once it's quite tight, that's usually fine. All right, so I just need to insert that washer and the strain relief. It's all in place. And now what I'm going to do is I'm going to close the unit. Just make sure there is no wire in a place where it would be cut off. For example, if I ran the wire over there, it would be pinched when I put the lid on. So notice it's only, the wire is only in the gaps here where there are recesses. Right, so the unit is reassembled. It's now plugged in, and there you can see the unit has been repaired. Thanks for watching, and cheers.